Hello all, hope you all are doing fine. Welcome back for another question from Inverse Trigonometric Functions chapter, class 12th. This is a proving question where we are given two terms on the left hand side and one on the right hand side, and we have to prove them equal. So let's begin. Let's first read the question. Question says something like, we have tan inverse of root 1 plus x minus root of 1 minus x upon root 1 plus x plus root 1 minus x on the left hand side, and on the right hand side we have pi upon 4 minus half into cos inverse x, and we are given the domain, or we can say range of x, that is minus 1 by root 2 to 1. I mean our x cannot be smaller than minus 1 by root 2 or greater than 1. It can be equal to both of them. Okay, let's dive into the problem solving. So let me give you the idea first. Whenever you see this type of term, let me highlight it. Whenever you see this type of term where something is given under the root and something is written like 1 plus something, 1 plus x, 1 plus t, 1 minus t, anything, but it should be like root of 1 plus something. So you must immediately get the idea that we are going to use the two identities in this question. Let me first write all those identities. I am using the different color. The first identity is that sine square plus cos inverse cos square is equal to 1. I am not writing the x. Okay, let me write the x. Sine square x plus cos square x is equal to 1. The second identity is cos 2 theta is equal to 2 into cos square theta minus 1, and the same thing can be written as 1 minus 2 sine square theta. I hope you are getting it and you know how to transform between this the first one, this one, and this one. You just simply use the first identity, this one. Replace cos square theta by 1 minus sine square theta and you get the same identity as written here. You get this identity. So we are going to use these two identities in this question. So don't look at the hint. Okay, by the way, we are going to use this hint only. So what we do, we replace x by cos 2 theta, and you must get the idea that as soon as we replace 1 plus x by cos 2 theta, we can use these identities. We can transfer 1 to here and we get 1 plus cos 2 theta is equal to 2 cos square theta. When we replace x by cos 2 theta here in this term root 1 minus x, you can see that we can transfer 2 sine square theta to the left hand side and cos 2 theta to the right hand side. So we get 1 minus cos 2 theta is equal to 2 sine square theta, and our answer or the expression becomes easier. So let's dive into the question. Yes. So what we do? We first replace x by cos 2 theta. We do this thing. What do we get next? We get this thing. Now root of 1 plus cos 2 theta can be written as root of 2 sine square theta from this thing by using LHS and RHS. This thing. We transfer 2 sine square theta to the right hand side and bring cos 2 theta to RHS, and we get something like 1. This was plus. Okay, we are not going to use this one. We are going to use this one. I'm sorry. Let me erase this thing. Okay, I just made a mistake. This is sine square theta, 1 minus 2 sine square theta. Yes, sorry for the delay. Okay, so we have 1 plus cos 2 theta here. So what we do, we transfer 1 from this side to this side and we get something as 1 plus cos 2 theta is equal to 2 cos square theta. That's written over here, 2 cos square theta. Similarly, 1 plus cos theta is cos 2 theta can be written as 2 cos square theta. Now comes root of 1 minus cos 2 theta. So for these we take help of these two terms, this one and this one. What we do? We transfer 2 sin square theta to the left and bring cos 2 theta to the right and take the root on both sides. So what we get? We get root of 1 minus cos 2 theta is equal to under root 2 sin square theta. So this is the same thing. Moving to the next step, the above expression can be simplified to this one. Root 2 comes as it is and cos square theta comes as cos theta from the root. So we get root 2 cos theta minus root 2 sin theta upon root 2 cos theta plus root 2 sin theta. Now the next step is that we cut all the root 2 and root 2 things. So we get cos theta minus sin theta upon cos theta plus sin theta. Now what should be our next step? We can see that we have tan inverse on the left side. So if we can somehow convert this thing, this the highlight underline part, if we can somehow convert this thing into the formula of tan x minus tan y upon tan x plus tan y, or tan x plus tan y upon 1 plus tan x tan y, those formulas I am talking about. So if we can somehow convert this term to into those formulas, we can easily simplify our question. So what we do, our next step is that we divide the numerator and denominator by cos theta. When we do that, we get something as 1 minus sin theta upon cos theta upon 1 plus sin theta upon cos theta. Let us move to the next slide. Yes. So what did we get? We get tan inverse of 1 minus tan theta upon 1 plus tan theta. Now I hope you all remember the formula of tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. If we compare these two terms, we can see that x is equal to 1 and y is equal to tan theta. I hope you can easily see this. 1 minus tan theta upon 1 plus 1 into tan theta here. So we can write it as tan inverse 1 minus tan inverse of tan theta. Now tan inverse of 1 is pi by 4 from the principal value, and tan inverse of tan theta is theta. As we all know, tan inverse of tan theta is equal to theta. We apply this identity, so we get our answer as pi upon 4 minus theta. Now remember our initial assumption. We took cos 2 theta as x. Now putting the value of theta here, we get our answer as theta is equal to cos inverse x. Am I right? Theta is equal to cos inverse x by 2. So we get our final answer as pi upon 4 minus half cos inverse x, and we just proved that LHS is equal to RHS. Hence our answer is solved. I hope you all got it. Thank you.